Hi, and welcome to the tutorial for running correlations in SPSS 18. So as a reminder, correlations reflect the amount of association or the degree of association between two variables, or you can also think of it as how do two variables covary with one another. Typically, when we run correlations, we are running them with two continuous type variables. There are ways to do correlations with other type of variables, and those will be the focus of other future tutorials. So let's go ahead and run a correlation using our data in SPSS. We're going to go ahead and go to Analyze. We're going to go down to Correlate and Bivariate. Bivariate means that each correlation we are running is between two variables. What you'll see here is our list of variables in our data set, as well as the variables in which we are correlating with each other. So in this data set, what question I'm interested in looking at is how does depression associate itself with mental health? So let's go ahead and find our variables. The variable names for the ones I'm interested in is dep02 and men-OH. So we see here it's dep02. You can go ahead and press Shift to select neighboring variables and click. And then that you'll move both variables into the variables list. Those are the only two variables I'm interested in correlating for the purposes of this example, so that's all I'll need in there. Let me go ahead and give you a little bit of an explanation about each of the things that you see here on this menu. Pearson R is our typical correlation coefficient. However, if you're interested in non-parametric statistics, we have Kendo's tau and Spearman's rho. Both of these use some aspect of rank ordering in order to calculate the coefficient. Next, for tests of significance, you'll see that the default is the two-tailed test. However, if you have a directional hypothesis, you can go ahead and select one-tailed. And this last thing here is flagging significant correlations. What this will do is that it will put an asterisk next to your correlations that are statistically significant. This is always the default and also a very handy feature, especially as your correlation tables get very, very large. All right, let's go ahead and take a look at the options. So you'll see here options, means, and standard deviations. These are just your descriptive statistics. And you can see that these are generally built into each one of your tests, and you don't have to go and do a special descriptives analyze if you're interested in only running this correlation. You can still get it here. Another thing you get is the cross-product deviations and covariances. Generally, if you're only interested in the Pearson R, you're not going to be selecting this option. However, if for the purposes of a class or anything like that, and you might be calculating the Pearson R by hand, this covariance that is put out here and the standard deviations that is also put out as a function of this option will be simply the unstandardized version from which we calculate the Pearson R. So it actually gives us our number of how these two variables covary together. The Pearson R gives us a standardized version of that. Next, we see this box right here for missing values. You have two options here. You have exclude cases pairwise or listwise. For pairwise, which is the default here, it means that you're going to include the individuals on which there is data, that means no missing data, on whichever variables you're correlating. So let me give you an example. So for example, I'm interested in not only looking at depression and mental health, but I want to throw in physical health in there. But one individual does not have any physical health data. So when the program gives me correlations between depression and mental health, that individual will be included. However, for any correlations that involves physical health, where that individual does not have any data, that person will be excluded. However, with listwise, the other option, what that means is for any variable that's listed in this variables list right here, if there's missing data on one of them it will exclude it from any analyses. So going back to my example using mental health, depression, as well as physical health, if someone was missing data on physical health, they would not show up even in the correlations for mental health and depression. So they're thrown out of all of the analyses if they have a single missing data point on any of the variables listed. A quick trick for knowing which one was selected is that when you look at the sample sizes for your correlations, if you selected pairwise, you'll see likely different sample sizes across each of the different pairings. However, for listwise, you'll see the exact same number across all of the different correlations. Okay, let's go ahead and press continue. We're not going to select anything. You can go ahead and press paste or OK. I'm going to go ahead and show you paste. Select paste, and a syntax window should pop up like so. I'm interested in just running this correlations syntax. Select it as I have done, and press on the green play button. Your output should come up, and what you'll see here is our Pearson correlation between depression and mental health. What you see is a pretty strong negative association. We use Cohen's guidelines to determine the strength of association. And what this means is that as mental health increases, depression scores decrease. Alternatively, because it is a symmetric correlation, you can say as depression scores increase, mental health decreases. The important thing to note with the negative correlation is that they move in opposite directions. Okay, so let's go ahead and also show you how to do a visual depiction of this correlation. So what we need for that is to do a scatter plot. There are two ways of doing so, and let me show you both of those ways. We go to graphs. Your first option is to use the chart builder, but there's also the option of using legacy dialogues. The first one I'm going to show you is using legacy dialogues. This is usually my favorite. I'm interested in doing a scatter dot graph, and it's a simple scatter. I'm just interested in having the program put out all of my data points onto a graph, and we're going to press define. I'm going to go ahead and select depression as my y-axis, but it does not matter which one I select. And I'm going to select mental health as my x-axis. I want my program to label my cases by ID in case I'm interested in identifying any particular case. You can go ahead and press paste or OK. I'll show you paste again. Your syntax window is already up, so now you have to go to it. Select graph, that's the only syntax I'm interested in running right now, and press the green play button. What you see here is our graph of all of our data points. What you see here is a pretty strong negative correlation as was indicated by our Pearson R. You can see this direction right here with a little bit of clustering down here at the bottom. This clustering just means that many of our individuals fall in a pretty good mental health score and very low levels of depression, which is what you would expect for the average person. You'd expect in a big sample that many people would sort of fall on the low end of depression and have at least moderate levels of mental health. Now let's say I'm interested in also making it a little bit clearer what direction my correlation is going in. Go ahead and double click on the chart. Your chart editor will come up. I want to insert a line that will show me the direction of how these points fall, or like the trend of the data. Go ahead and go here to this button right here, which is the add fit line at total. If you select it, it's going to add a fit line that runs through the points, and we want a linear line. And now it makes it even clearer what the trend of my data is, which is a negative trend right here. We have one individual who seems to be not following this trend. So we know that the trend is that as mental health increases, depression decreases. We have one individual who has very low mental health, but no symptoms of depression. And this is entirely possible, of course, but he doesn't seem, or he or she does not seem to fall into the trend of our data. So let's say I want to identify this person and I want to go ahead and just double check to see if there was a data entry error or a coding error. Now you have two options to identify this individual. First option is to go to Elements and go to, oh, hold on. We have to make sure we click off and click in. Oh, let me. All right. Well, I guess let me show you the second option. So go ahead and use this data label mode, which is the kind of, it looks like crosshairs. Select that and put it over the individual in which we are interested in knowing the label for, and voila, the label comes up. See, so any individual that I'm interested in identifying, you can use this function to do so. That's the, you can click it off, press OK, and you can go ahead and select out of this. So typically, if we were to do the other option, what we would do is we would double click, we go to Elements, and we'd hide data labels. Let me get rid of everything. And then what I want to do is show data labels. The downside of using this option is that it shows the data labels for all of the individuals, and as you can see, it sort of gets very complicated to read the labels, and that's where the gun crosshairs come in handy, and we can go ahead and hide those data labels again. Right? We can cross out here, and we still get our linear line. All right, so that's just a visual depiction of the correlations, and it's a nice feature to help you identify not only what the numbers mean, but also visually what it means for how our data fall on this graph. All right, I hope you enjoy creating correlations using SPSS, and I will see you next time.